Hey everyone, this is Ashwin. In this video, we are going to start a fresh topic that is deep learning. So this project is a basic project of a deep learning that is image classification. So in this project, we are going to recognize handwritten digits using image classification. So the input will be an image consists of a number and we are going to recognize that image using a small deep learning model and try to classify the image according to the digit. That's like an overall objective of this project. So this interface is completely new for you guys. So far we have done in a Jupyter Notebook that is in my local machine. From now on for deep learning projects and everything, I'm going to use this Colab. This is Google Colab. If you just type in Google like Colab, you can just go through the first link. It will show a page like this. You can create a new notebook from that. You will get a Jupyter Notebook structure similar to our local machine. So here you can see if you hover over the RAM and disk, you can see we have 12 GB of RAM and 107 GB of disk space. So this is like a large amount. Even if you don't have a powerful local machine with a GPU or other specs, you don't need to worry. You can use this Colab for any projects for machine learning and deep learning. Or else if you want to go with some other environment means you can also use Kaggle environment. They're also giving a similar kind of setup. So if you don't know how to set up the environment means just click on the right corner. I have created a separate video for creating the environment for machine learning and deep learning. You can explore that. Now this notebook is only using the CPU. In order to use GPU, press runtime, change runtime type, change it to GPU. If you want to use TPU means you can also use TPU, but you have to code it accordingly. I'm going to go with GPU. Maybe we can cover this later on a different video. But if you compare both these performance means TPU is much powerful than GPU. So people prefer TPU for advanced deep learning projects. Right now, I'm going to select GPU. Okay, let's save it. So it will just restart your runtime. So it will initialize all the things. Now it's connected. So it says GPU. And you want to use your data, right? I have downloaded the data from Analytics Vidya. Just click on this folder option. You can see a sample data. This is the space available. This is like a temporary space. You can just run it and leave it as it be. Just right click and click on upload. This is the data I'm going to upload. So it's already saying a reminder. Uploaded files will get deleted when this runtime is recycled. Just press on OK. It means the data will be deleted after you close the notebook. So this is like a temporary version. If you want to use it from your Google Drive means you can just click on this mount drive. It will automatically generate a code and you can use it further in order to process the data. I will use the similar setup maybe in the next video. For now, we can go with the temporary one. So I think it will take some time to upload. Let's leave it for a while. So the environment is almost similar to this Jupyter notebook. You can create a new code or create a markdown tab using this tabs itself. Click on text. Maybe we can say it as import modules like this. Now let's import all the modules until the data is uploaded. Now import pandas as PD, import numpy as NP. As you are already seeing, it's already giving some suggestions while typing. So it will be very helpful for you guys. From tqdm dot notebook import tqdm. So this will give us a loading screen kind of thing. So you can just see how much the progress has been made for that particular function. I will just use it while loading the images so we can track the progress. Now from keras dot preprocessing dot image import img image to array. and load image. That is like a basic pre-processing technique for loading the image and converting the image to a NumPy array. And next we need to import TensorFlow. Import TensorFlow as TF. This is like a backend module. Usually keras use TensorFlow as a backend. If you want to install TensorFlow means you can also install TensorFlow GPU or TensorFlow CPU. If you have only CPU version means you can just type pip install TensorFlow GPU. So this will install TensorFlow GPU and you can just directly install keras like this. You can just add it like this. So I'll just comment it here. Now after TensorFlow, we need to import matplotlib.pyplot as plot. And again matplotlib inline. Lastly, we need to import some warnings. So import warnings dot filter warnings, say ignore. I think that's it for importing the modules. And this, okay, I missed a n here. N, run this again. Okay, all the modules have been loaded. Let's see. I think it's still uploading. Now we need to unzip the data, unzip the train data. So we will be doing some Linux command, that is dot unzip, I think, the train data. So this will unzip the data we have. Currently it's been uploading, so we don't need to do this now. Let's create some codes and a text box. So load the data. Okay, I'll just wait for a while until the uploading is completed, and after that we will just process. So as you can see, the data has been uploaded. Let's run this cell now. Now it's extracting all the images we have in the train.zip with this folder, and we will be having a CSV also. Let's see what happens. Okay, it extracted all the things. Let's go down a little. Okay, we have a train.csv also. Let's see the folder structure. So we have train.csv here, and images have train and test data. So I'm going to use only train for testing and validation. So I think it won't show here because we have so much data inside this folder. So this is the folder structure we have. Let's load the CSV file. So that will be df equals pd dot read CSV. Let's ignore this error. Now train dot CSV. Let's run this. So this is the CSV file we got. So for each file name, we are getting the label for that file. So 0.png will be of label 4. So 4 digit will be in this file. Like this, we need to load all this data into a variable. Like we need to convert this image into an array, and after that we can able to process it. Okay, let's check what is the current directory path. For that, pwd, let's run it. So this is the path we are in. So let's create a variable called image path equals images slash train slash, and this file name can be appended to this one. So let's run this. Let's add some code. Okay, now we are going to load all the images into a variable for processing. Let's say the input variable as x equals. I'm going to process into a list comprehension. So it will be like a single line. I'll just segment it by multiple parts so you can understand it easily. First, we need to convert this overall in an array. So that will be np.array and again in a list. So I'm going to add more functions to it. So image to array of load image. Now we need to set the path, that will be image path plus df of file name. Okay, it's created another one, file name of I. So it will iterate each file. So this I will be in the for loop. And now we need to set the size. That will be target size. We already have that information, that is 28 cross 28. So 28 cross 28 comma 1. So this image, so these images are in grayscale. That's why I am using the channel mode as 1. So this is width and height. So this will be channels. So if it's 3 means we'll be having RGB. So it will be in color format. If it's 1 means it will be in black and white. That is grayscale. And another one, that is grayscale equals true. So the function can understand it is a grayscale image. So we have completed this whole function. Now after that, we need to have a for loop. For I in tqdm of range of train dot shape of 0. So I will explain why I am doing this. So train dot shape of 0 will get the length of the whole training data set. You can also say len of train. So this is somewhat much preferable. So 0 will get the number of rows, that is equal to length of train. So this is range, as you already know. TQDM will display the overall process. So for each images, it will show a loading bar. That's why I'm using TQDM. So for each iteration, it will load the image and convert this image into an array. So that is the overall step. And finally, we will converting. Let's leave a tab. Now as type of float32. Float32. I'm going to convert this NumPy array into float32 data type. So that will be easy for processing. Okay, I think we have done the loading part here. This is simple, so you can use it easily. Let's run this. Okay, train. Oh, we have used df, so that will be df.shape. Let's run this. So as you can see, there will be a loading bar and it's displaying how many images are processed right now. So if you have more number of images means this loading bar will be definitely helpful for you. Now we have loaded all the images into this variable. Now we need to load the output column, that is y equals df of label. Now that is the output. Let's run it. Now we have loaded the input and output data. Now let's print the shape of both input and output. Print x dot shape, comma, y dot shape. Run this. So we have 49,000 samples and the input shape is this. So 28 width, 28 height and one channel, that is grayscale. If you have RGB means we will be having three channels and the output attribute, that is we have 49,000 samples. Okay, let's do some exploratory data analysis. Exploratory data analysis. So I'm going to use some basic exploratory data analysis. Maybe in the future videos, like in Kaggle competitions, we'll be going with some advanced plotting techniques. So you can see various plots in a single image. Now I'm going to show you a basic plot. Let's have an image index. So image index equals, let's say 0 for now. Print y of image index. So we will be knowing what is the output variable. So image underscore index. So this will give us the output value. Now we need to plot the image. Plot dot im show, that is it will show the image. Now x of image index dot reshape, that will be 28 cross 28, comma cmap equals grace. So this is a grayscale image. Okay, let's try to display the image. So this is number 4. As you can see, the image is not that much clarity. Let's again close this. So this is like a basic thing. So this is like a 28 cross 28 image. This is like a small image you can think of. So each square boxes you can see, each one is a pixel. Based on this pixel values alone, the model will be classifying the output. Let's do this for another image. Let's have image index as 10. So this one is 2 and the output value is also 2. Let's display 100. So this one is 7. As you can see, there are different varieties of handwriting. You can see this is not much of a 4. It's like a slanting one. 2 is somewhat good, but 7 is also, it should be in a straight format, but it's somewhat different. So these are some basic exploratory analysis. Okay, let's divide the input split for train test split now. Add the text, train test split. So we are already done it before using sklearn. Now from sklearn dot model selection import train test split. So it's automatically suggesting all the functions. So it will be easy for you. Now xtrain, comma, xtest and ytrain, comma, ytest equals train test split. Okay, it's not suggesting now because it didn't import. Now x, comma, y and the test size can be 0.25. Now random state equals 42. And lastly, I'm going to introduce a new parameter, that is stratify equals np dot array of y. So what is the advantage of this parameter is this will split the test data with uniform class distribution. Let's say we have 100 samples and we have 20 samples for test data. We are almost having 10 unique classes, that is 0 to 9. So it will take test data for each class. So for each class, it will be having two test data. Like that, it will split. If you don't mention it, so it will split randomly. So we won't be covering all the test classes. That's why I am splitting like this. Now let's run this. After this, we need to do a basic pre-processing. Let's call it as normalization. Normalization, that will be x underscore train divide equals 255 and x underscore test divides equals 255. So I am going to divide the pixel by 255. Before that, let's see what are the values we have in the data. X train of 0 and this. So all are having some 0 columns. Wait, you can see these are some pixel values. All are having a range of 0 to 255. That is the range of the pixel values in the grayscale. Why I am going to normalize means we will be having the values in between 0 to 1. As I already discussed in many videos, we need to have the range with a small difference in order for the model to better classify it. That's why we are using like that. Okay, I think we can comment this now. Now we are going to run this. So we have normalized our data set. Don't run it again because it will divide the input again by 255. So it will mess up the data. Now let's see what happens now. X underscore train of 0. Run this. Now let's see the input. How is it gonna be? So as you can see, so the inputs are in the range of 0 to 1. This is like almost close to 1. That means it is 255. That's the assumption we are getting. So model can easily recognize with the small differences. Okay. Now let's come on this. Okay. Now we have done all the pre-processing and splitting the data. Now we have to create the model. Okay. Model creation. I'm going to create a basic CNN model for this project. For that, we will be importing some modules from keras.models import sequential. These are some attributes or modules we need to use from keras.layers. These are the layers we are going to add. Import dense, con 2D, convolution 2D. So this is like a 2D image. Dropout. So dropout is used to avoid overfitting. This will include some regularization for this project. So to add some regularization for the dataset, I'm going to use dropout and flatten. This will flatten a 2D array into a single array. Lastly, max pooling 2D. Yeah, this one. So this module will take the maximum pixel values to the next layer. That's how it works. This is like a simple explanation. Maybe we can cover this each modules in detail in a theoretical part, maybe in later point of view. First, we will know how the application works. After that, we can go about that practical stuffs. So it will be more useful for us. Okay, let's create the model. Create the model. Now model equals, the first step will be sequential. Sequential, that is a function, and model dot add conv2d, that is the convolution neural network, conv2d, and again So the pixel value input is 28, right? So that will be 28. This is like a number of hidden units. Just increase the hidden units gradually, and while reaching the output, you can decrease it gradually. Like that, you need to form the network. Next, kernel size equals, I'm going to use 3 cross 3, and input shape, input underscore shape equals, okay, let's define the input shape before. So input shape equals, we already know 28 comma 28 comma 1. So we'll be using the same variable here, input shape. Now this is like a first hidden layer. Now model dot add. After the convolution layer, we need to use max pool. There are many pooling layers. You can use anything you want, but you need to have some theoretical knowledge about that. Now pool size. Okay, we need to specify underscore pool size equals 2 comma 2. Okay, now I'm just going to flatten the input. Model dot add flatten. This is like a smaller neural network. You can see I'm just adding one hidden layer here. So it's not that much of a big one. So you need to use flatten before the fully connected layer. And after this, model dot add dense. Dense is the fully connected layer. Fully connected layer means it will be like a linear layer with all the samples in a linear array, like a single dimensional array. Dense will be 128, comma, activation equals tf dot nn dot relu. This is the activation function I'm going to use. And after this, I'm going to use a dropout layer, model dot add dropout. Okay, dropout. We need to specify some percentage like we have did in test size. So I'm going to specify it as 30%. It means 30% of data from the dense will be dropped out. So it will avoid a overfitting. Now after that, model dot add again a dense layer. This is like a final output layer. The number of output is 10. So I'm going to specify 10. Or we can also specify here output class equals 10. Let's run this. Now output class, comma. Now again activation layer, activation equals tf dot nn dot softmax. So we have 10 classes. Based on this activation layer, it will have higher probability for the corresponding class. So this softmax will do that. So if you have some binary classification means you will be using some sigmoid or some other activation. So it depends. So based on this activation only, your output classes is defined. And these are the model we have created. Now the last step of compiling the model, model.compile. Okay, compile optimizer, optimizer equals Adam. So this will automatically adjust the learning rate for the model over the number of epochs. Now loss equals sparse categorical cross entropy. Okay, I think I spelled it right. So this is like a loss function for the model. So this is like a basic structure you need to specify for all the neural networks. And finally, the matrix. Matrix equals accuracy. Accuracy. Now we have created the whole model structure. So this is like a basic model you have seen. So this can be replaced with any code you can get from the internet. And so this is like a basic compilation. This will automatically adapt the learning rate, and this loss function is used to adjust the gradient descent. So all the theoretical concepts, just leave it now. I'm just explaining in practical terms. So if you don't understand means it's not a problem. You can always use the model and able to use it for some other applications. And finally, this is a classification problem. That's why I'm going to use the matrix as accuracy. Let's run this. Hope it not shows any error. So it's compiled. Now model.fit x equals xtrain, comma y equals ytrain. Okay, sorry, ytrain, comma. So here you can see all the parameters for the fit function. So you need to have a batch size and the number of epochs, verbose, everything it's having. And we do also have a validation split. If you don't split the data like I have done before, you can set the validation split here like 25%, or you can specify the data here on validation data, and you can also shuffle the data. So these are some additional parameters. Let's specify the batch size. Batch size equals 32, and epochs equals, let's say, 30. And lastly, validation data, we will specify x test, comma y test. I think that's it. This is for training the model. Train the model. This is define the model. Okay, let's run this. Unknown loss function. I think, sorry, entropy don't have h. Think, let's run it now. Yeah, now it's working. So this is like a complete iteration. Each epoch will train the data set, like it will train the whole data set. So that is considered as an epoch. So now it's training. So this is training accuracy. This is validation accuracy. As you can already see, we have 98% accuracy. So we have the results directly. I think 30 epochs is too much for this data set. And also you can see this is like a simple model. It's not even like 5 layers of CNN. If you have like 5 layers of CNN means you need to have a sufficient amount of data. Right now, I'm just having a less amount of data. That's why I'm using a small neural network. So we already reached 99% accuracy for training, and for testing, it's oscillating, I guess. 98.38 is like a highest one, and it's still oscillating. Let's see what happens at the end of 30. Maybe out of this validation accuracy, we may need to pick the best one. So far, we have seen like 98.38. Yeah, we have reached that again. Okay, I think it's gonna be completed now. So we have got the highest accuracy, validation accuracy is 98.38, and for training we have got 99.59. Don't train too much, it will overfit the data. We need to specify the number of epochs reasonably. And you can see this 1149. This is like a number of iterations in each epoch. That is like a number of batches. For each batch, it will process 32 images. Like that, I have specified. If you have a larger GPU, means you can increase the batch size, like 64 or 128. It will be in terms of 2 powers. That is everyone will be using. And I think that's it for training. Let's do some small testing here. Testing the model. Again, we will use that exploratory code. Okay, now I'm just displaying the training image. Let's treat it original output. Okay, now prediction equals model dot predict. So instead of this, I'll be using X test, and this will be Y test. Now predict X test of images index, image index dot reshape 1 comma, that is like one sample we have, 28 comma 28 comma 1. This is the input shape. This is the number of sample we are going to subject to the model. If you are going to pass the whole data set, means you just ignore this value and reshape like this. And let's print the protection. Print predicted output, that will be prediction dot argmax. So it will be in terms of an array with the probability ranges of each class. So argmax will display the highest probability. Let's run this. Okay, we don't have that much of an key. Let's say 10. Okay, this is like a data frame. Maybe we can just comment it out. We can directly see the image as an input, and we can see the output directly. Let's run this. So predicted output is 1, and the image is also 1. Let's change it to next index. Maybe we can copy and paste it for the next one. Let's say 100. Run this. Now the predicted output is 8. Image is also 8. So we have trained a deep learning model that is like a small neural network, and we have got 98.38 accuracy. So this is like a basic image recognition problem, that is handwritten digits recognition. Like this one, you can just change the input and output parameters, and you can use it for many applications like face recognition or flower recognition. Like this, there are a plethora of applications. So feel free to play around with this parameters in the layers, and you can also add some new layers if you want, and see how much the results varies, and leave the comment below if you got some higher accuracy than this one. And I think that's it, guys. So this is the analysis of image classification. If you like this video, hit the like button, and don't forget to subscribe the channel for future videos. Stay tuned for the next video.